43. No, 43. Let's do that one. 5, -2 is the point. And let's see what it's asking us. P is a point on the terminal side of theta in standard position. Find the exact value of the 6 trig functions for theta. P is 5, -2. Well, luckily I have this picture right here, so that's helpful. 5, -2. So x is positive 5, y is -2. So -2 maybe is right here. X is 5, so maybe it's right here. And so you have this vector right here. Okay. And let's see what we're asked to do. Find the 6 trig functions. Well, you need to know what R is, right? Well, R, using the formula that we learned yesterday, is what?
X squared plus y squared.
Okay, yep, x squared plus y squared, so that's 25 plus 4, so that's 29, right? That's just x squared plus y squared. All right, well, calculating the 6 of them, I'll just do the first 3 with you. Sine of theta, well, that's y over r. Y is -2, r is square root 29, so that's -2 root 29 divided by 29. Right? So that's all it is. I'll do cosecant with you. Well, that's just r over y. You can choose which one you want to do now. It would make sense to flip this one, right? So this is -root 29 over 2. Right? So we're good with that? Okay. All it is find what the radius is, and then remember how these are defined. Sine is y over r. Cosine is, that's for you to tell me, cosine is x over r. Tangent is y over x. Cosecant, secant, and cotangent, those are just reciprocals. Yes? For 42 through 49?
No,
26, 27, 28. So those are all asking for, oh, it's saying to draw an angle? Okay. So you're just drawing an angle.
Oh, I just didn't know what it meant.
So standard position means the initial side. Let's do a better color here. So it's a good question. Initial side, it's starting on the positive x-axis. That's all it means for standard position. So, does that help?
Yeah.
Okay. Yep. All right. Any other ones from the homework, or are we good? Good. All right. So, here's what I would take down for your notes today. We've got a little bit to do, and then we've got some drill and kill we have to do. All right? Don't do much drill and kill in this class, but we're going to for the unit circle. Nope, I'm going to ask that you do it by hand. I know. This is now 13.3. Yes. Is this hard to see? Well, I'll do that tomorrow, but you should be able to see this. If not, you need glasses. Can you see it better? Are you good? There's room up here if you want to squeeze in. You can put the chairs up. I'll do that tomorrow, though. Yeah, I'll put it up tomorrow. Okay, so have you ever heard of a radian before? Some yes, some no. Okay, well, what's a special word that looks like it's inside of radian? Radius, right? So let's look at this. I want you to, even if you know what a radian is, I want you to look at this for a second. So let me restart this so you can see it from the beginning. Just watch it. We'll go through it once or twice, and then we'll talk about it. There's your. If you wrap it around the circle, that's an arc subtended by this angle. This angle is called 1 radian. Okay, so let's keep watching. How many are there in 180 degrees? Pi radian, or 3.14. How many are there in 360? 2 pi radians. Let's watch it one more time so it makes sense so you can write it in your own words. If you want to know what a radian is, you look at a circle with radius r. If you look at the angle that's created by giving you an arc of length r, this is the radius, that angle is 1 radian. So this is how a radian is defined. 1 radian. It is, exactly, it's the angle.
It's like that arc made by like the length of the radius.
It's the angle that has the property that it takes up. If you look at the arc, it takes up 1 length, which is equal to the radius, right? So it's that angle. So when you're talking about a radian, you're talking about an angle. Or if you remember from geometry, there's a special word for this, the angle subtended by this arc. So the angle that's subtended by an arc of length r, that is 1 radian. Okay? The angle subtended by an arc of length r is 1 radian. All right? So if that was hard to understand, well then just have this definition down as well. A unit of angle measured based on arc length. So you have 2 ways now to measure angles. One way is in here. 2 ways to measure angles: degrees and radians. So it would be helpful if you can convert between these 2, right? And sometimes I might give you it in radians, sometimes I might give you it in degrees. So let's write down these conversions. Yeah, if you want. I mean, it's helpful. It's just XY plane. And also showing you 2 important numbers. 180 degrees is pi radians. 360 degrees is 2 pi radians. Conversions, that's what we're going to work on today. So before we start doing calculations where we have to do them by hand, let's just do some that are in our head. If you know these 2, you also know a couple other ones pretty quickly. If 180 degrees is equal to pi radians, what's 90 degrees worth? Right, pi over 2 radians, right? Half of pi radians, pi over 2 radians. If you wanted 45 degrees, then how many radians is that? Pi over 4. Or what if you wanted, how about this? What if you wanted, let's see, what's another one? 135 degrees. 135 degrees. How are you going to find that in radians? You could do it kind of in parts, right? So we'll practice a couple. So for these two, let's do it together. Go from degrees to radians, or from radians to degrees. And I'll just walk you through these ones slowly, although you can probably do it on your own. I'm trying to go from degrees to radians, so what needs to be in the denominator? 180 degrees. So times this by pi rad, that's radians, over 180 degrees. Degrees are going to cancel. And let's see, negative 60 over 180 is a reduced fraction. Negative 1/3. I still have pi radians. So this is equal to negative pi over 3 radians. So ask a question if you're not seeing how some of those calculations are coming up, yeah?
I was like, kind of is virtualization like a unit? Is it like similar to writing like the degree sign?
Yes, it's similar to writing the degree sign. This is just a unit we're measuring by, right? Sometimes you might measure by centimeters, sometimes you might measure by degrees, sometimes you might measure by kilograms. This one is just like all those units, but we're talking about radians. Yes? That's true. Yep. And just like how there are different ways of measuring weight, right? Maybe you do kilograms, or maybe you do pounds, right? There are different ways of measuring things. Yes.
I'm still just kind of wondering why like negative 60 turns into that.
Okay, so somebody explain to me, how did this negative 60, and it's not just this one, how did this go from here to 1/3, negative 1/3? Carol?
Never mind.
Oh, wait, I thought we got it.
Yes?
So basically you would have, it would turn into negative 60 over 180, and then since you can reduce that, it would reduce to 1/3, and then you just
There you go. Nice explanation. All right, well, let's go the other way now. I'm trying to go from radians, so what needs to be in the denominator? Radians, right? So times by 180 degrees divided by pi radians. And you can see some things are going to cancel here. Pi cancels with pi. Radians cancels with radians. And what I'm left with is 180 degrees over 3. 180 degrees over 3, or if I divide that out, oh, I forgot my 2. This should be 2, so we should still have a 2 times that 180. So that just switches this number. So that's what? 2 times 180 is 360, divided by 3 gives me 120. Yep, nice catch. All right, so is converting seeming okay? No? Okay, we'll just try another 2. You try these ones with your group mates, and then check with the neighbor. So take 2 minutes, convert, and then check with your neighbor. Or ask somebody next to you. Okay? Maybe ask somebody next to you.
Did you just, yeah.
36 over 180, anybody get that as a reduced fraction?
Yep.
What's that?
It's basically just
1/5? 1/5? So just remember the radians is when you say RAD at the end, that's the same thing as putting a degree symbol, right? Except this is a different unit. This one is radians. If it were degrees, I would have put degrees. Okay. So for the first one, your answer should say negative pi over 5 RAD. Right? Negative pi over 5 rads. Yep.
Do you put the radians always next to the fraction, like you would put that on the, like,
Right, so you know, this is radians over 1, so it could go in the numerator. But usually you'll just say it like this. It's negative pi over 5 radians.
and then also, that's still technically like 5.
Say it again.
I'm just like confused because like, you just like get rid of the degree sign so that it's not degrees anymore?
Well, so remember, if you wanted to, let's just do an example with centimeters or something. Let's see, 150 miles per hour. If you travel for 5 hours, how far did you go? Hours cancel, so you went 150 times 5, 150, 200, 300, 450, 600, 750? 750 miles. Right? That's how units work. They cancel. Okay. Here's a quick one. We'll do mental math. 2 pi is worth how much? 2 pi radians worth 360. So how much is 4 pi worth? There you go. 720, right? 720 degrees. So make sure you put the units. All right. Good with converting? Okay, we're getting there. Yep. All right, let's see. Trying to go from degrees, so degrees need to be in the denominator. Negative 36 is the same thing as negative 36 over 1, multiplying across, or just putting what? This is saying negative 36 over 180, right? These are multiplying, so I can arrange them however I'd like. Pi radians is up top as well. Simplify this. If you simplify 36 divided by 180, it's the same thing as 1 divided by 5, and that's how we get here. All right. Now we're gonna learn something fun, and it's gonna be a little bit of a uphill at first. Okay, trying to learn the unit circle. It takes practice, so you cannot go into this next assessment not studying. Have to study, all right? This unit circle takes studying to understand. So let's get this down before we start doing some just straight practicing. Unit circle, what's in the name? A unit. That's 1, right? Unit circle is a circle with radius of 1, right? So keep that in mind as you're writing this down, and then we'll talk about it. Does any of the stuff on the screen look familiar? Yeah. We saw it. We saw it not too long ago. In fact, we saw it yesterday, right? You saw this yesterday. Okay. So remember yesterday, we had this, what's on the screen. You had some angle from some point, and you were asked to tell me sine, cosine, tangent of that angle theta, right? Well, you needed first to find out what r was, right? Well, lucky you, on the unit circle, what's r? 1, right? Well, just from what we did in the warm-up today, right? You said sine is equal to y over r. Well, what's r in our case? 1. So sine of theta is equal to y. Cosine was x over r. Radius is 1. X divided by 1 is x. So that means my y components are going to be sine. My x components are going to be cosine. Tangent is still going to be the same. Y divided by x. Do you see how it relates to yesterday? Okay, good. Now, let's see, is there anything I really want to say on this page? Any questions you have on this page? Yep, Dennis?
Just to make sure, you said that all y values would be sine and then all x values would be cosine?
Right. The coordinates are going to be written as cosine, comma, sine. All right. So, good. Here's what we're going to do twice today. We're going to fill in this unit circle. You're going to do it once, hopefully thinking a little bit, but I expect you just to copy it down, not thinking, right, and just copy it down. The second time when you go back and fill it in, I want you thinking about the values and thinking about where they come from. And what I mean by that is this. If you look at this, and I'm just going to give you an example of how I do it in my head. If you look at this as an xy plane, what's the degree here, and what's the measure of the angle here in degrees for this line? 0. Well, what do you think it is in terms of radians? 0. What's some other ones I know? This one's pretty easy. This one should be how many degrees? 90. How many radians was that? We did that a couple seconds ago. It was pi divided by 2, right? So in radians, it's pi divided by 2. Oh, I know this one too, 45. 45 degrees. That one was pi divided by 4. Okay, so do you see how you can start filling in stuff you know? So some of this you're going to be able to fill in on your own, but I want you to go to page, let's see, I think it's 900 and... Say it again? 944?
Yeah.
944, and I'm going to pass out the page that you're going to fill in. 944. And that's on Schoology, or you can grab a physical book. Why don't you send somebody up from the front of the row to grab some of these sheets that you can give to each other. There's a front and a back, because you're expected to do it twice.
I'm just trying to be helpful.
There's extra. See, I'm going to give you about 12 minutes to work with each other and do it on your own, and then I'm going to walk you through how I think about it when I do it. Okay, so you guys discuss, or just work on yourself. See how fast you can do it, right? 944. No, they're not. We're drilling and killing.
Yes.
So if you've done it once, flip it around, do it twice.
The look.
It's good practice though, right?
I bet there's an app for this where you could like practice it, like you know, your friends will think you're texting, but really you're practicing your unit circle.
You might want to try it.
That's what the cool kids are doing.
So I'm going to start filling in mine, and I'm going to ask you for suggestions. I totally forgot, right? Where's a good place to start? What's the easiest thing I can fill in on this unit circle? Maybe all the degrees, right? Okay, I'm going to start there. 0, 30, 45, 60, 90. It goes another 30. So that's 120. It goes 15. That's 135. It goes another 15. That's 150. It goes 30. That's 180. It goes 30. That's 210. Okay, so that one was nice. Next easiest thing to do would probably be the radians, because that's just converting. 0 degrees, 0 radians. 45, pi over 4. 90, pi over 2. Now let's see. Now it starts getting a little tricky. Well, let's see. 30 degrees. 30 degrees. What is that in terms of radians? How did you figure that out? Mm-hmm. There you go. So pi divided by 6 is 30. Pi divided by 6. All right. Next one, pi over 4. The next one, let's see. What is the next one? 60 degrees is what in radians? Well, how many of those do I need to get to 180? 3, right? 60, 120, 180. So that must be pi divided by 3. Now let's look here. Every 30 degrees, I go how many radians? Pi over 6. So here's 30. Here's 30. So this was 1 pi over 6. This should be 2 pi over 6, which is the same thing as pi over 3. If I go another pi over 6, that should be how many pi over 6? 3 pi over 6, which is the same thing as pi over 2. So I'm trying to help you through the idea of how to walk through these. If you go another 30, if you look at this as a pi, now I'm 30 degrees more. So let's see. That was 3 pi over 6, so this one should be 4 pi over 6. Let's go another 30. 5 pi over 6. Let's go another 30. 6 pi over 6, or that's just equal to pi. And I can go back and simplify. 4 pi over 6 is the same thing as 2 pi over 3. Let's see. I'm already doing the top half and I'm almost done, so we might as well keep doing that one. 45 was pi over 4. I went another pi over 4, so that's 2 pi over 4. If I go another pi over 4, how many are here? 3 pi over 4. So this one should be 3 pi over 4. So do you see how you can fill these all in? Just kind of go at regular intervals, right? And you'll be able to do this. This was 6 pi over 6, so let's keep going with the 6's. If I go another 30, that's 7 pi over 6. If I go another 30, that's 8 pi over 6. Oops. 8 pi over 6, which is the same thing as 4 pi over 3. If I went another 6, that'd be 9 pi over 6, which is equal to 3 pi over 2. I would have gotten that same number had I done pi over 2's. 1 pi over 2, 2 pi over 2, 3 pi over 2. Do you see how that can help you fill in these numbers? Okay, you can probably fill in the rest now with those ideas, but let's think about the x and y's. If I look at this as xy plane, this quadrant right here, which one's positive, which one's negative, or are any negative? They're both positive, right? X is positive, y is positive. How about this? On this side? Okay, so next, x is going to be negative, y is going to be positive. How about in this quadrant? Both negative. And then in this one?
X is positive, y is negative.
There you go. That's helpful. Here was the trick I was talking. This is probably the hardest thing you're going to have trying if you try and remember it. But if you view it as right triangles, you will never have any trouble. That's a right triangle. Do you agree? What's the measure of this angle? 30 degrees. What's the measure of this radius? Because we're on the... Okay. How big is this side compared to the radius? Or how about this? What's the radius equal to? Right? So if question mark is equal to A, I know the radius is double that. So if I want to solve for A is equal to 1/2. Make sense? Well, what is that? Is this an x value or a y value? Why is it a y value? Because it's going up, right? So the y value here is 1/2. Well, if I found the y value, which is the 30 part, what's the measure of this angle? 60. So what's the measure of this side? What's the measure of that side? You take A and you times it by square root of 3. So this is equal to There you go. So that means the x value here is square root of 3 over 2. Do you see how we do this? If you look in the middle, this is a what kind of triangle? 45, 45, 90. What's the value of both of the legs? Okay, they're both x. They're both x. How big is the radius? Radius is 1, and it's equal to leg times square root of 2. Solve for x, and you get x is equal to 1 divided by square root of 2. If you rationalize the denominator, yep, square root of 2 over 2. Do you see how you can fill in all this information just from knowing a few things? It's really important that you do, because sometimes you're not going to, you can see there's a lot of stuff to remember on this unit circle. Remembering it can be difficult, but if you know tricks to how to find everything, then you don't have to have it memorized. Yep. No, what was the question? Maybe somebody else had it. Well, maybe somebody else had it. What was the question? Sure, just convert it, right? That's a method. Convert it, right? Or just keep thinking about it as a clock. Every 30 degrees I go pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, right? And that's another way to fill it in. Every pi over 4 you go, pi over 4, 2 pi over 4, 3 pi over 4, pi over 4. Right? So there are different methods. Right now, just focus on trying to memorize it and seeing if you can come up with strategies.